intriguing, and it was very fun to be part of this event. Thank you so much for this opportunity.
Thank you, Padmini. Means a lot. Yeah. Lakshman, you want to give yourself?
Yes, sure. Yeah, I was just sending the link to Sharat. I think he's into the wrong meeting, so I was
No
just forwarding.
worries.
Yeah.
Yeah. Otherwise, I'll ask Priyanka and then you can join. You can go next. Yeah, Priya.
Okay. Hi, my name is Priyanka, and I'm a data engineer at Amazon. And I wanted to, just be part of this hackathon because I'm totally new to LLM, and it's good to learn new things, new concepts. And yeah, I did enjoy working with these guys actually. So
Mhm.
Nice. Very nice. Ashwin?
Yeah, so I'm Ashwin. I work as a software engineer at Notchdown in Seattle. So yeah, I want to deep dive into AI, LLMs, agents, and all those stuff. So yeah, participating in hackathons is a good way to do that, and also meeting new people. So
Nice. Hello, Sharat.
Hello.
Hi.
So,
Few lines about you. We are
yeah,
going through introductions, so.
yeah, sure, sure. I by mistake joined the Google Meet link, but yeah, I got it now. Yeah, I'm Sharath. I am working at Nordstrom as well, as a software engineer, and yeah, I joined this hackathon just to work on AI projects, get to speed on them, and then also I'm curious about how to build some applications out of it, which will solve real world problems. So yeah.
Very nice. Thank you. Lakshman?
Yes. Hello. Hi, Eden. Hi, Padma. Hello, team. I'm Lakshman. So I work at AWS as a software engineer. Yeah, I just saw the hackathon and then I thought it would be really fun building AI applications. So that's why I signed up. It is fun. And I have not worked with the multi-agent systems. I worked with building agentic stuff, but not multi-agent systems. So this was fun, like
Super.
building this for this project. Yeah.
Super. By the way, I run a company called VirtuTech. We are AWS advanced partners in data and AI. So we give data and AI solutions to our customers. Since you said AWS, I thought of mentioning that. Okay, Eden.
Hey guys, so thank you for taking part in this. You are one of the first to submit the project amongst the various teams, so you've done a very good job, obviously, and I'm really excited to see your presentation. On a personal level, I work in product management at Google on our Gemini models, and I'm always kind of very excited to see where people can take LLMs and what sort of challenges they encounter along the way, but also the type of magic it helps them create. So I don't know how you solved the public safety problem that we gave you, but we're going to find out.
And I want to add one thing. Actually, this whole hackathon idea and the push came from Eden. So it's, I think without his support, I think we would not have done this. So thanks, Eden. Thanks for your support. Yeah, go ahead, guys.
Okay, just quickly share my screen. Let me know once you're able to see my screen.
Yes, we are able to.
Awesome. Okay, so we are Hackathon Team 13. Welcome to our presentation. So quickly going over the agenda. So we'll be talking about introduction, the choice of topic, our project name itself, and a quick rundown of our team's portfolio. Of course, we introduced ourselves. It'll be just pretty quick. Followed up by our objective, what is our problem statement, and our goal, which can lay a foundation for what our hack itself is. And then we'll continue discussion around the overall architecture and a quick simulated demo. Post the conclusion, we'll talk about the impact this application actually can create in the real world scenario, as well as the future considerations and takeaways and key learnings from our end. So introduction, the topic which we have chosen is a smart disaster response using multi-agent systems, and our project name is ASAP. The choice of the name itself is to actually ensure the communications are more real and swift in case of a disaster event which occurred, which basically ASAP nothing means autonomous search and assistant protocol by itself. The team members, we already introduced ourselves. Three of us are from Amazon, and two individuals are from Northstown. So the objective and the problem statement, and we'll have a high-level overview of the goal for our project itself. So this ASAP protocol is basically uses or leverages a multi-agent framework, which is designed to respond to any disaster events immediately and also assess and detect the situation by itself.
Padmini, we're
Yeah.
still seeing the title slide. I don't know if you're still there.
Yeah, when I
Yes,
was
we are not
Oh,
looking at the presentation. We're just looking at the PowerPoint
okay.
window.
Okay. I did do a screen share. Just 1 second. Apologize about that. Let me do a share of the window if the entire screen, maybe that works. Okay. Can you see the slideshow right now?
Yes.
Awesome. Okay, so we went through this section, just running down pretty quick. ASAP is our project, and that is nothing but autonomous search and assistant protocol. So the next section will be talking about the objective. So basically discussing the problem statement, the goal which we picked up. One of the inspirations for us to actually pick up this, or the choice of the project itself, is the recent fires in LA, which inspired, like, we have to come up with something which can actually help in a real world scenario. And LA fires is something which popped up in our minds when we thought about it, and that's what intrigued or made us to actually choose this topic itself. I just wanted to lay it out there. So our system goal for this ASAP protocol basically is to support real-time data ingestion, that is, receive and process asynchronously the sensor data from multiple sources. Robust decision-making techniques. So we have leveraged LLMs to make the decisions on any of the rescue actions and the mission itself. The dynamic task allocations, which is configured based on the rules. We'll talk about it more in detail when we talk about the simulation demo itself. So ideally, it's focused on dispatching tasks to the specialized agents to do or complete the mission based on the priority as well as in available resources. The feedback and logging, which is very crucial in this process to keep the system more real-time updated. So it's continuously, the agents are giving feedback to this control system, and also like configuring information or providing assistance to the humans on the next course of action. So the simulation focus was majorly to mimic the real world scenario, sensory inputs. So we have also considered thermal images from like for the human thermal images, the distress sound of a humans for our evaluation, and to see how this model can fit in and support the real world applications. So going in detail with our hack on how the use case was implemented and the overview itself. The architecture design is basically like supports any integration with the real world devices. It can be supports like drones, ground bots, sensors, or in case if you want to think about having an integration with helicopter in futures, which still can support that. So the key features here is the sensor data integration, where we collect the real data from the drones and robots. And we've also brought an integration with the weather API, the gas emissions, and the human reports. The human reports actually takes a precedence compared to the other data from the devices itself. But still the decision layer actually falls into the central command system, which we'll talk about in a bit. So once this data is being collected from this external sensors, the data is aggregated in an aggregation module, which basically collects all the information and draws a meaningful insights from this source feeds. So this information is then fed into the command system, which basically consolidates all the data which has been obtained from the aggregation model, and which prepares a list of tasks and the action items, which is sent as an information to the task allocator. The task allocator takes a stab at all of the action items which is being provided by the central command system and sees which is the best possible solution or best possible agent to actually accomplish this task. Maybe it can be a drone or it can be the ground bot to take that action, and how the communication can be sent back to the central command system to be making aware of all the things which is happening in and around, and also the status of that specific agents itself. So the entire architecture is just completely based on the simulation for rapid prototyping as discussed, and with the simulated environment itself. So the design is fully scalable, and it can be integrated with a number of devices, like the drone sensors counts can be increased, and or the bot sensors per se, based on however we want to leverage this application itself. So we also actually created a mock-up integration of a UI, which actually gives us a look and feel of how the real-time updates will look like. Just a call out because we didn't have sufficient time to integrate our backend database to the UI. Right now, the UI actually is mocked up with a sample data. So it simply means when we simulate the data, it may not show up in the UI, but we would definitely walk through in the UI how the overall interface will look like. So the ASAP architecture components overview itself. So how this entire architecture supports multi-agent. Each drone and robot itself acts as an independent agent by itself. So we will leverage Redis queue, which acts as a message broker, and the agents use that to publish and subscribe the events. And also the agents register with the task allocator, which basically is responsible for allocating the task or directing the agents to perform the necessary actions. So Firebase was used as a backend layer to support the real-time reporting. Right now, all the information is captured in the Firebase, and the only catch is like we have not integrated to the UI, as stated before. So the multi-agent coordination has been established among the agents. What is the need for this? So the need for this is like for dynamic reallocation mechanism. Say, for instance, agent is actually in a mission and there is some catastrophic event, like say, for instance, system failure. So there is coordination among the task allocator realizes, okay, there is no heartbeat or information received from the specific agent, and it needs to deploy another agent in course of action to complete that mission. And also, we also track all the information related to the location, the health status, the agent status, the drone fleet status, to actually decide which particular agent is suitable for that specific mission to be completed by completed itself. So the agents are also stacked in the queue, and responsibility is being split across the respective agents. So in this way, we are isolating the respective task, and there is no a failure of one will not result or impact other agents which is on that particular location. We have also leveraged Anthropic Cloud OPS model, which is the data-driven linguistic interaction and the decision making based on the aggregated data which we have at our end, which is later processed into the command center for the next course of action. For the UI, we've used Tailwind and deployed using TypeScript. So on the right-hand side, you will see the snippet of our UI. So it basically talks about the status log, which gives the status of the drones, which is being deployed, the drone fleet status, the carbon emission, which is around it, what is the health of it, the agent status. And there is a messaging box right above the weather conditions, which talks about the commands which we can provide. We can monitor the location, the feedback, where the humans can key in the feedback or retrieve the status of a specific agent on the latest information of, or if you can give a particular zip code to understand what are the particular bots which is in that area, if there's any concerns per se. All of this information will be available on the UI to leverage or make any critical or take any critical decisions. So the application highlights. So the first one to call out is the modularity, because the agent acts as it's isolated and it's independent by itself, and the reusability of the components. So we can definitely leverage this framework for upgrading to work independently, or leverage into a different projects or for enhancements itself. Scalability, it's easier to add new agents or modify the existing ones. I can think about a scenario where, like, imagine you have to deploy this application in a region like Hawaii, like in the Big Island, where it's a volcano prone zones, and you would not want to have ground bots, and instead you would like to have drones, which can take a more or it can give more information and can operate more efficiently. So that way we can include new agents and modify based on a specific location, and it's scalable. It's a fault tolerant architecture, and it's fully isolated because one agent impacted will not impact the overall system. The system is still operational and running. Parallel development, we can work on different agents and simultaneously, like I stated, the Hawaii situation. So you can have different agents operating at different locations, performing different set of activities. And overall, the reusability of application and also reusability of the applications is very high and can be scaled and enhanced further for other use cases as well. So this is a bit of more detailed walkthrough on the multi-agent workflow and how the command center interaction itself will look like. We will discuss more on the simulation demo. Lakshman will be taking over from here to work on like how the command center interaction will look like, and also demo on how like the data will be simulated from the bots itself and how the tasks are being assigned. Over to you, Lax.
Thank you. Let me take over the screen sharing.
Sure, thanks.
Great presentation, Padmini.
Thank you.
Let me know when you can see the whole screen.
Yes.
Awesome. Okay, so let me pull this up. Yes, let me quickly run through this workflow. This is the core of the system, and we'll jump straight into the demo and show different components, how it will look like and how it will feel like, and so on. So like how Padmini mentioned, the data aggregator collects data from multiple sources, from on-field drones, from on-field robots, from on-field first responders, weather data, chest data, gas sensors, whatever data that we can think of, it can just be plugged in with ease. That's one of the advantages of the system that we have built. This is very flexible. It's very easy to plug in multiple sources of data and everything. So this is super flexible and so on. So what this data aggregator does is it takes all this collected information and then it converts it into a useful way. So it filters out unwanted informations, and it takes into account all the informations that is received, and it tries to group them, classify them, uh, and see if it can like relate all those informations. Since this is a disaster recovery, so they are primarily grouped by the location and timestamps, and also the task or the mission that this 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 specific event is deployed on. So it takes all those data, and we use intelligent systems over here to respond to image data, to respond to gas sensors. We get raw data. How do we make sense of it? We use intelligent systems. And we also take into account the human reports, which is usually natural language. We take into we take into those as well, and then we make a decision. We forward that to the decision engine, which is basically the command system. This command system is essentially a task planner, and like very similar to all the agentic systems out there. This command system creates out a detailed plan of execution, and then it then sends to the task allocator. This is the breakdown of the task allocator over here. So so we can the task allocator could use multiple conditions, multiple techniques to prioritize the tasks. And then the next, what it does is it also understands what are the available resources it has. It has drones, ground bots, or we could add any kind of autonomous agents to this. All it needs to do is register to the task allocator and with its capabilities. And the task allocator intelligently identifies which task to assign to which specific agent. So this is one of the techniques that we really solved, and we don't think any current disaster management systems that currently do have. This is kind of a unique proposition that we propose. So rule-based systems, we have to work on it to accommodate different types of actions, different types of agents. This, it's really flexible. So since we use LLMs in the background and also machine learning and AI agents in the background, we are automatically able to understand the system's capabilities and the task in hand. So we are able to allocate the task to the specific agent. And the task is dispatched to that agent, and then that agent is given its reign to go and accomplish that task. And so an even deeper look over here is this piece. This is an example. Let's consider we have two drones that is available and a ground part, and this is how the task allocator communicates with them. The task allocator finds out the best drone or the bot for the task, and then allocates it to them. And then all these bots like periodically sends back a heartbeat back to the task allocator with essential informations like battery, like where it is, what it is doing, and also like it gives back the feedback about the task complete. That's basically if the drone is able to find out human survivors, or if the drone is able to find out any new fire, or if the drone or the ground part is able to find out any gas sensor, like hazardous toxic gas sensor readings, thermal images, normal image, everything. Like it sends back the information, and then the loop goes back. It goes back to the decision engine, and with the new information, the decision engine restructures its plans, and then it sends back. So this is real time. It dynamically adapts based on the real time information, and till we achieve solving this disaster, like responding to it, saving it, the system is going to keep running. Yes. So given this diagram, I'm just going to go here and show you how the dashboard will look like. So this is the dashboard that we're looking at, what the humans will be looking at. So the operators, they'll be having access to this dashboard. They could see different drones over here, and they could send specific commands to the drones over here, start mission. These are all human controls. They will be responding autonomously, but I'm a really high believer of having humans in the loop, because we just don't want to have systems that is running rogue. You need to have human in the loop. So we have like sufficient information over here that we could send it to instruction that we could send it to the bots. And we could also send real-time events. We can see like what each bot is doing, and we can see like commands, and then we can see battery level percentages. We can see sensor readings from different robots, and so on. And we can also see the real-time activity that it is going on. If any task is assigned, we can look at the status logs, and so on. So we could do all these things, and we also know like what bot is doing what task over here: active patrols, searching, assist the medical team, and so on. So yeah, and we could also provide human feedback over here, fire in building, and we could send it, and then this command system could plan a series of action, like verify if there is a fire. Once it sends out a robot, once the robot sends back information that there is a fire, then like with the new information, it makes a new set of decisions and action items to follow. So this is how it is. So this is a map. It displays where each agents are, but our API key is broken, so we couldn't see it here. So going back to the backend, we also get critical alert responses so that we could act appropriately. So going back to our actual backend systems of the agentic systems, we have multiple agents over here. We have command system, data aggregator, drone, groundbot, task allocator. So each of these agents are autonomous, independent, and they make their own decisions. So every agent communicates with each other through the workflows, and they have a common goal that they want to achieve. So I'm going to reset this, and I'm going to start the system, and this is basically starts a Redis queue, so that and then I'm going to start a simulation over here. So what I'm going to do is I'm going to simulate a human message. We could simulate different messages, different responses, but I'm going to start with the human report. So if you look at the human report over here, we say like we essentially get a report from some human first responder who says there is a fire in the building, there is lots of flames. Survivors in the top floor of the building need immediate assistance. So this is kind of the command that they are sending. We could easily plug this into any existing systems like Citizen or other data sources, data collection, like publicly available systems, and it should work readily out of the box. So all these informations are just metadata, and this is basically the human input. And once we run this, uh, did I? Oops. Yeah, that's my bad. Okay. If we do this, we have just sent this data to our systems, and then we can see the system has started processing. So we have sent that data to the data aggregator, and then data aggregator starts responding. So the data aggregator has processed the information, and it has sent it to the command system. So we can see the live logs over here. So this is the same input that we have got. And then this is what the data aggregator has from the human response. And this is what it has been, it interpreted. So this is all real time. We use live systems, we use live LLMs. We have fine tuned it for our use cases. And and here's what the response from that. So we could see this is the process data hazard. Infrastructure is basically from the building that we have said, and it says active fire, risk to property, fire location within the building, and we could see like all these data that has been interpreted by the data aggregator, and this has been sent to the command system. So this is the input of command system from the data aggregator, and we could see command system taking actions from it. So with that information that command system has, it takes these actions. It created these actions over here. So which is basically like the first task is to respond to the fire. First and foremost, we need to dispatch aid. So that like whoever human is there or anyone, any survivors over there, we need to respond aid to them, and then it goes to them. And here next we see the next task is to search to see like inside the building if there is any other uh, people. Like we can also see the context over here that it has created. More information needed on the fire location within the building. So everything has been created right now. We could look at the timestamp. This is all live feed that it is making decision based on the available responses. And the next thing is, yeah, it's the same. It's just another print log of this. And the command system is passing this information to the yeah, it's just like printing multiple times. Okay, the command system is passing the information to, oh, okay. Oh, oops, sorry, I was looking at the I was looking just at the command system log. Okay, this is a consolidated log. So we can see the data aggregator, we could see the command system agent, and we can see like the command system agent has sent it to the task allocator, and then the task allocator finds out like, okay, these are the tasks in hand. This is the first task, and this is the survivor search rescue. It has interpreted from this. This is the first task it has. And then it says, this is the context. Locate the exact number and the location of the survivors in the building, and it has the capabilities and so on. This is the input payload. And based on that information, the task allocator has created these tasks. First is it finds out the drone bot. This is the rescue drone 3, and it assigns a task over here to search. And we can see a human, like, why does it allocate? We need to know all those informations. So for human observability, we have added this reason, human understandable reason, and we could see the reason why task allocator chose this specific drone bot 3. So this is the most suitable bot for the search rescue task because it has the necessary capabilities to scan the disaster area, take pictures, uh, detect hazards as fire with altitude as high as 200 and battery level of 78%. So we could see like what are all the different factors that it is taking into consideration before it could actually like go and make a decision. So we can understand why the drone bot actually chose this. And so the task allocator takes this and it knows which drone to assign to, and then it dispatches this message to the actual drone bot. And these are all the second tasks. So I will go to the next bot first to see like what happened in the drone bot once it is dispatched. Okay, so here we could see the drone bot agent. So like it has multiple tasks, so it is assigning multiple tasks. We could see the next one is survivor rescue 2, and then it sends a ground bot and so on. So the task allocator takes multiple tasks in hand, and then like it assigns it splits across the available resources. And if it could not assign
Lakshman,
it, yes,
sorry to stop. Eden has a question.
yes, Eden.
No, I just wanted a quick time check because we're over time. So maybe we want to go back to the presentation if there are additional final slides.
Eden,
Yes.
do you have something else, a meeting, or we can give them, they're talking so passionately. So how much more time, Lakshman, you need?
I could, if like 5 minutes, I could run over this page, and then we could just I would finish the full loop, and then we can go back to the presentations for the final slides.
Is
Okay,
that
okay. I
okay,
think
Eden?
that, yeah, the dashboard I felt is a very, very good kind of showcase for
Right.
the experience of using this.
True.
But if you feel it's important for us to continue with the code, we can do that. But I think the dashboard
Yeah.
was slightly more useful to me.
Okay. Yeah. Yes. So basically, like the main thing that I wanted to point out here is we have actually simulated the drone bots, and then it actually reads like the camera images. So we have simulated it. So we are this project actually simulates the entire images like these, and it takes into account all these images, and we are processing these in real time as part of this project. So yeah, that's the one over here. And then like these images from the drone bots which have been deployed, it constantly sends back the inputs to this command system, and then with the newly available information, it changes, and then it just goes on. We could see like it has been running, making more decisions, and yeah, that's the idea over here. Going back to the slide, uh, yes, Padmini, do you want to take over?
Yeah, sure. The overall project focuses on proactive alerts and swift rescue operations in case of any of these events. And as discussed, we can have different sensors being deployed, bots being deployed at different location based on the use case, and we can actually enhance the life-saving efforts. Lax, you can move on to the next slide. So the future considerations, one of the things which we wanted to highlight with the deployment of this application is like real device integration. So we can simulate, right now everything is simulated sensor feeds like how Lax walked us through. This can actually be a hardware using ROSO2 on other API devices, and it can also be a distributed deployment system, scale agents across multiple missions using services like Docker. Advanced decision-making techniques integrate with reinforcement learning models, which can actually take more decisions around the task prioritization itself. And also from the security and robustness point of view, simply because right now, because we are giving precedence to the human, we also want to ensure so it's not being violated, and the authorized personnel actually takes in charge, and also implement a multi-failover strategies, at least for the command centers as well as the task allocators, to prevent the overall failure of application. Multi-agent consensus protocol is also one of the key things to actually enhance this overall application itself. And the further communications, right now, we have not integrated with communication to the first responders like hospitals, ambulances, or even the fireplace. So that would be a good to have so that they're well informed in case of there's any survival victims and they need to be ready for any assistance, or they need to jump into for a next course of action. So these are the future considerations and takeaways. And that concludes our presentation. Thank you so much, team Padma and Eden, for being patient with us and giving us an extra time. And I hope you guys enjoyed our presentation. And if you have any questions for us, we're happy to answer. Thank you.
Great job. Great job. Yeah, I do have a couple, and maybe I'll go first and then Padma. So two things that you may have covered, but I'm not sure I've seen them. One is, LLMs are not always super reliable. They can make errors. You did talk about the human in the loop, but is there any mechanism there for perhaps one agent to challenge the decision of a different agent to verify something before, like one of the task allocators' decisions? Do you have some sort of second opinion mechanism
So
there?
yeah, so we use this is essentially not an LLM. So you're using a multimodal foundational model in the back end, which like Opus is a multimodal foundational model which could deal with multiple things along with language. And yes, so challenging the assumptions is baked into the system, especially in the data aggregator and the command system, which filters out and verifies it. But it is not in the task allocator piece. Task allocator piece, we don't verify it, we don't challenge it. But like in terms of the first two agentic systems that we have, we do challenge it. Like it doesn't take all the information into account. Wherever it needs verification, it deploys additional mechanisms to actually verify. And in those payloads, we have a confidence score that's part of the response itself. And based on the confidence score, that's what like the task allocator makes a decision over there. And talking about yes, LLMs are not good for all the tasks that we have specified here. So we with the limited time for the hackathon, we chose this. But if you look into our repositories, we have specified which model is exactly suitable for each of those tasks. Or YOLO could be there for human identification or the human mapping. Or Google has a model where we could easily like identify thermal like humans within the thermal images, even with low lights. So we suggested all those models, which could be easily plugged in. So yeah, this was for the hackathon. We did a fast prototyping.
Okay, yeah, thank you. And second, last question is maybe somewhat related to that. So let's say during an event itself, the central command, I think, or the task allocator, takes certain action. Are you then looking at the outcome of that in order to sort of feed it back into the next decision within that same event itself?
Yes, yeah, that was the
That's
part
one
that
of
I
the
wanted to
arrows.
spend. Yeah, that was the part that I wanted to spend a couple of more minutes on, but I couldn't reach over there. So essentially, there is a feedback loop at every step, and the command system takes into account like the data aggregator before sending the information to the command system. It puts together all the accumulated information, tasks, bots, previous actions, new informations, events collected from different data sources. And also, like let's say it dispatches a drone, it takes picture, that's also information related to that. So we take into all those system accounts, and then the task planner accommodates like dynamically changes the plan, and that's also available.
Well, I guess, okay, so I totally get it that you always feed all the information that's available, including past information, but do you do anything in particular to make sure that the LLM sort of understands the causality? Basically, here is what happened, but this is what I did, and did it lead to the right result? And if not, do I need to do something else? Do you think that's kind of part of the system?
Not right now, but that's where the future plan of introducing reinforcement learning to update the system to keep on learning it based on the input and output. That's where we think it might fit in, but we don't
But
have it right now. Yep.
yeah, but also the idea is to have that feedback being sent to the control system so the humans who are actually monitoring the system can monitor the latest status on whether the mission was successful or not itself. Yeah,
Okay, thank you.
thank you.
Great job, guys. I don't think particular I have any questions. I like the way how you break it and the design and how you thought through. I think I like that piece of it. Yeah, yeah, of course, this is like what in 3 days, 5 days, you guys have accomplished this in less than a week span. So, so I think nothing much more to ask you guys. I think whatever Eden asked, I'm good.
Thank
Good
you.
job.
Thank you so much.
Great job.
Thank you.
Thank you.
Thank you. Thank
Okay,
you.
April 5th plan. Come at 9 o'clock if you want to participate in that speed hackathon. Okay. So that's enough. And then sit down and code, and that's there. You don't have to be in a team. You can do it separately. But if not, please be there by 1 p.m. because
Okay.
that's when your presentation will be given again in front of all judges. So that's
Okay.
how we planned it. Okay.
And how much time,
And
Padma, is it for each presentation?
I don't think there we are not even thinking of maybe 30 minutes, 20 to 30 minutes, guys. So time it, okay?
Yeah, we'll definitely time
Because
it.
yeah, here I know I requested Eden, and here my next meeting is at 9. So,
Yeah,
but
thank
there
you.
there we also have like we have to again Lakshman and Padmani. Yeah, we are doing this. We need volunteers. Next time I want you guys to be part of this. Let's give to the community back. So that's the concept behind. Okay.
Sure. Sounds good.
Okay.
Thanks, Eden.
Thanks everyone.
And
Bye.
Thank you so
thank you.
much.
Take care. See you.
Thank you.
Bye.